Hi everyone, welcome to Nithin Academy and I'm Nithin. And there are many things new in this chapter. In Secondary 1 Science, I will be moving on to the next chapter, Atoms and Molecules. So, let's dive straight into it. Okay, so for the first segment of this video, I'll be going through what is an atom. Okay, so what is an atom? So this is what an atom looks like. So what is an atom? An atom is the smallest particle of an element. Okay? So an atom is actually the smallest particle of an element. So we all know there are 118 elements, right? So there is like hydrogen, nitrogen, oxygen. So all these are examples of elements, and each element, so for example hydrogen, has hydrogen atoms. Like, okay, so each element has its own type of atoms. So basically elements are made up of atoms. Okay, so matter is made up of atoms, and we all know that the elements are also part of matter. Okay, so all the atoms of an element are identical. Okay, so they said all the atoms of an element are identical, but atoms of one element differ from atoms of another element. So atoms of one element, okay, differ from atoms of another element. So for example, if this is gold, okay, and this is silver, okay, that means that gold atoms are different from silver atoms, but they are still atoms of different elements. Okay, but all gold atoms are the same and all silver atoms are the same. So that's what this second point is trying to say. Okay, next, there are 118 elements, meaning that there are 118 different kinds of atoms. Okay, so like the example I just gave, so all gold atoms are the same, but they are different from silver atoms. Okay, so this is basically the learning point here. Now let's move on. Okay, for segment number 2, I'll be going through using models to represent atoms. Okay, so we are going to use models to represent atoms. Okay, so how can we represent atoms? So first of all, we can use ball and stick models. Okay, so scientists use ball and stick models to show how atoms are arranged in the substances. Okay, so this is an example of a ball and stick model. So basically each ball represents an atom and each stick represents the force that holds atoms together. Okay, so basically what is this entire figure over here? So this is actually known as the molecule, and I'll go through about the molecules later in this video. So what we need to know right now is about the ball and stick models. So basically just take note that each ball represents an atom and each stick represents the force that holds the atoms together. Okay, so I hope you understood that. Okay, next, the size of an atom. Okay, the size of an atom is dependent on its mass. Okay, so each element has its mass number, right? So due to this mass number, we will know what's the mass of the atom. So if hydrogen has a certain mass, right, the atom will have a certain mass. Okay, so that's what we can learn from the periodic table as well. Okay, since atoms vary in size, a small atom would usually be represented with a ball smaller than that used to represent a bigger atom. Okay, so I hope you understood that. So this is pretty common sense. Okay, so I hope you understood that. Atoms of different elements can be represented using different colored balls as well. Okay, so for example, hydrogen can be used to be represented with a blue color ball, while nitrogen can be represented with a green color ball. Okay, so you know what I mean now. Okay, so That's what it is basically. Now let's move on. Okay, so this is an example of a ball and stick model as well. So with some different sizes of balls and also different colors of balls. So over here we have the example of hydrogen and chlorine atoms. So basically we are drawing the compound hydrogen chloride here. So basically the hydrogen atom is a white color ball which is small. So it is white and small. Okay, while the chlorine atom is actually orange in color and is actually bigger than the hydrogen atom, because chlorine actually has a bigger mass than hydrogen, and thus it is in a bigger size and in a different color, since it is a different element itself. And you all know what the stick is. So the stick is basically the force that holds these two atoms together. Okay, so I hope you understood that. Now let's move on. Okay, so how can we represent atoms? Second off, we can use circles. Okay, so this is an example. So different colors. Okay, so basically different colors or patterns of circles represent different atoms. Different sizes of circles represent different atoms as well. Okay, so for example, different colors and patterns. So there are actually many different patterns. So as you can see, this is one of the patterns, like drawing lines inside a circle, basically making it look shaded, and one blank circle, and one blank circle, and also we have the circle which is fully shaded in. Okay, so I hope you understood that. So there are actually different types of patterns, and there are patterns you can create on yourself to represent different atoms. Okay, and you could also represent it in different sizes. So you could have a if imagine hydrogen. So basically you can have a small circle with shaded, while if you have chlorine, you can have a bigger circle which is not shaded. Okay, so you could write chlorine inside and hydrogen inside, or if you don't need to. Okay, so I hope you understand what I'm trying to say here. And with that, let's move on to the next. Okay, so how else can we represent atoms is by using chemicals. Okay, so what we are going to do is that the scientists actually use the chemical symbol of each element to represent an atom of that element. So we can obtain it from the periodic table. So basically, like hydrogen is represented by a chemical symbol of H, sodium is represented with a chemical symbol of Na, nitrogen is represented with N, oxygen O, carbon C. So I think you understand what I'm trying to say here. So chemical symbols can also be used with circles. So you could have different colored circles, different sizes of circles, different patterns in the circles, and you also add on with the chemical symbol. So what's the first circle here? So as you all know, this is the hydrogen. This is hydrogen atom, and this is the nitrogen atom, and lastly we have the oxygen atom. Okay, so you can see how they are being represented with the chemical symbol, also different sizes and also different colors. Okay, so I think you understand what I'm trying to say here about representing atoms using models. Okay, so we are all good, and now we are ready to move on. Okay, so for the third segment of this video, I'll be teaching you how to use a model to represent a structure of an atom. Okay, so let's get on with it. So how do we use models to represent atoms? So first of all, we have to know what are atoms. Okay, so this is the big question. What are atoms? So this is what an atom looks like. So atom means indivisible. So atom is actually not an English word. It originates from somewhere else, and it actually means indivisible. Okay? In the center of an atom is a nucleus. So So you see this part over here, this is actually the nucleus. Okay, next. The nucleus is actually made up of protons and neutrons. So in this nucleus, there are actually smaller circles such as protons and neutrons. Okay, just 1 second. So the red color circles are representing protons. So these are protons and these are neutrons. Okay, so moving on. Nucleus of an atom is positively charged. Okay, so positively charged meaning the nucleus is actually +1. Okay, an atom is neutral. Okay, that meaning it is actually not a positive charge or a negative charge. So neutral equals 0. Okay, so every atom has the same number of protons and electrons. So you should know by now that protons are actually negatively charged. Okay, protons are negatively charged and electrons are electrons are negatively charged and protons are positively charged. Okay, and neutrons actually have no charge, which means they are neutral in charge. Okay, so every atom is neutral, so that's why there must be an equal number of protons and electrons. So P equals to E. So because plus 1 plus 1 is equal to -1, so this actually results in both charges cancelling out each other to give us a neutrally charged a neutrally charged atom basically. So I hope you understand what I'm trying to say here. And if an atom is not neutrally charged, it is not an atom. Okay, it is something else like an ion or cation. So actually these are things that you're not learning in sec 1 right now, but you'll learn it later in upper secondary school. Okay, so that's something important that you need to know. Okay, so let's move on. Okay, next off, what are atoms? Still in this question. So each atom is made up of even smaller particles known as subatomic particles. These are there are three types of subatomic particles. So basically the three types we have already talked about: proton, neutron, and electrons. Okay, so let's talk about this. So protons are actually positively charged, neutrons are neutral charged, which means they are 0, electrons are negatively charged. Okay, so this is the main idea here. So just remember, protons are positively charged, neutrons are neutral, it's in the name itself, and electrons are negatively charged. So a good way to remember this is to remember protons start with the letter P, right? So P stands for positively charged. So this is how I actually remember that protons are positively charged. Neutrons are actually neutral in charge because it is in the name itself, neutron. So basically just remember neutral charge. Okay, so that's how you should remember it. And lastly, electrons is the last result is basically negatively charged. Okay, so I hope you understood that. So now let's move on. Okay, so next, protons and neutrons are densely packed in the nucleus. So these are some things that we should take note of. Okay, so protons and neutrons are densely packed in the nucleus. So basically these are protons and these are neutrons. Okay, so uh, uh, the green color balls are basically protons and the red color balls are actually neutrons. Okay, and these are actually densely packed in the nucleus. Okay, next, protons and neutrons are also known as nucleons. Okay, so both of these are actually known as nucleons. Okay, Okay, next. An atom consists mostly of empty space. So this is the third point, empty space. So this is actually really true, as you can see over here. See that? This is empty space. This is empty space. This is empty space. All of this is empty space. So you get what I'm trying to say here, right? So an atom is actually mostly consisting of empty space, and here I am outlining it to you. Okay, so as you can see, all of this here is actually empty space. Okay, so as you can see, basically more than 3/4 of the atom is actually empty space. So electrons, okay, so moving on, electrons, so basically all of these balls over here move around the nucleus in electron shells or orbits. Okay, so let me just erase all of this here. It's a bit messy. Okay, so electrons are actually moving around the nucleus in electron shells or orbitals. So basically they are in constant movement around these orbitals. Okay, so these are called electron shells basically. Okay, so I hope you understood that, and I'll cover this more in depth later on in this video. Okay, so let's move on. So these are examples of uh, atoms. Okay, so this is how you represent it in a two-dimensional figure, and this is a three-dimensional figure. Okay, so let me just talk about that. Okay, this figure here is actually three-dimensional. Okay, and this figure here is actually two-dimensional. Okay, so meaning that this is the kind of drawings we use to represent atoms when we are actually doing our exam papers. So the teachers might ask, draw this atom or whatsoever, and we will actually draw it in a two-dimensional figure instead of a three-dimensional figure. Okay, so two-dimensional figure is something important that you need to know, and three-dimensional figure is just for you to learn right now. Okay, so let's move on. Okay, next off, let's talk about the properties of the subatomic particles. Okay, so what are the properties of the subatomic particles? Okay, so basically, subatomic particles, we all know that there are three types: proton, neutron, and electron. Okay, so these are the three subatomic particles. So basically, first property is we are looking at is their charge. Okay, so we all know that protons are positively charged, neutrons are neutrally charged, and electrons are negatively charged. And the location in an atom, we already know this as well. Protons are in the nucleus, neutrons are also in the nucleus. So basically both of these protons and neutrons are actually known as nucleons. Okay, next. And also electrons are found in shells or orbitals. The proton's relative mass is actually 1, neutron's relative mass is 1 as well, and the electron's relative mass is 1 out of 1840. So when we are looking at the mass, of an atom, right, we only take into consideration proton and neutron. We do not take into consideration electron, because the mass is actually really negligible. So okay, I think you understand what I'm trying to say, because proton is 1, neutron is 1, while electron is 1 over 1840. So you see the depth in that, right? Okay, so I hope you understood that. And also lastly, we are taking a look at the last part, basically the symbols. So protons are represented using a symbol P, neutrons uh, N and electrons E. Okay, and all of these are lowercase. Okay, none of these are uppercase, so please do take note of that. Okay, so now that we are done with that, let's move on. Okay, for the third segment of this video, I'll be going through using a model to represent a structure of an atom. Okay, so we are going to talk about this. So using models to represent atoms, basically still in that area. So properties of subatomic particles, we have already taken a look at this, but still let's take a look at it one more time. So the mass of one proton is actually taken as 1 unit. So subatomic particles, relative mass, proton has a mass unit of 1, neutrons a mass unit of 1 as well, electrons is 1 over 1840. So electrons actually have a negligible mass, so we do not take into regard about that, while protons and neutrons actually have the same relative mass, and this is actually really important. So each proton molecule and each neutron molecule is actually the same. So each proton subatomic particle and neutron subatomic particle are basically in the relative mass of 1. So both of them are having the same relative mass. So basically in an atom, so let me just draw the two-dimensional figure here. So in an atom, we have the electrons, and so basically we are having the same number of protons and neutrons, and even if there's not the same number of neutrons, it doesn't matter because the neutrons are actually neutral in charge. So the protons actually are 1 and neutrons are 1. So when we are taking a look at the mass of the atom, right? So for example, hydrogen, if hydrogen has a for example, hydrogen always has a relative mass, right? Hydrogen mass number basically in the periodic table, so it has some random mass number. Okay, so let's just take this as the mass number. So this is just a symbol. So basically this atom's mass is actually this symbol. So the proton plus the neutron is actually this mass over here. Okay, so that's what you need to understand. Okay, so I hope you understood that, and I'll go through this more in depth later. Okay, so let's move on right now. Okay, since the relative mass of protons and neutrons are much larger than compared to electrons, the mass of the nucleus contributes to the mass of an atom. Okay, so basically what I was trying to explain here. Okay, so let's move on. Okay, next off we have the properties of subatomic particles. So let's talk about this. All atoms are electrically neutral. Basically there's no net charge. This means that the number of positively charged protons are equal to the number of negatively charged electrons. So basically the positive and negative charges cancel out each other. So we have already talked about this, so I hope you know that by now. So for an atom, the number of protons is equal to the number of electrons. So this is really important. Okay, so I hope you understood this. So please do take note, the number of protons are equal to the number of electrons. So protons are positively charged, electrons are negatively charged, and these two cancel each other to give us a no net charge, basically neutral charge for an atom to be formed. Okay, so I hope you understood that. Now let's move on. Okay, next off we have the atom. Basically we are talking about the atomic number, the proton number. So each element has a unique proton number, you know that, right? So it is given to us in the periodic table itself. So the proton number actually gives the identity of the element. So atoms of different elements have different proton numbers. So we can actually find out the electron number, the number of electrons in an atom, using the proton number given to us in the periodic table. Because why? Because we have just learned the rule called all protons are equal to all electrons in an atom. So for example, if proton number is 6, right, we are gonna have 6 electrons in the atom as well. Okay, so let's take a look at carbon atom. So carbon is the 12th atom. Okay, so example, so this carbon atom actually has a proton number of 6, and meaning that it also has 6 neutrons, 6 protons, and any atom with 6 proton must be a carbon atom, because only one element can have a certain number of protons. So only carbon has 6 number of protons, so it can't have 5 protons or 4 protons or 7 protons. Only carbon can have 6 protons. Okay, so another element can have 5, 4, 3, 2, 1, any number of protons, but it can't be 6 because carbon has 6 protons. So I think you understand what I'm trying to say here. So an atom with 6 protons must be carbon atom. Okay, so let's just take an example here. If the carbon atom has 6 protons, how many electrons must it have? Must have 6 electrons as well. Okay, so let's move on. Okay, moving on. So where can we find the proton number of an element? So I was talking about this to you just now, right? So we can actually find it from the periodic table. So this is basically the periodic table here. So we have all the things over here. So we have hydrogen, helium, boron, carbon, nitrogen, oxygen, chlorine, neon. So all the elements are actually in this periodic table. And if you realize something, right, all the proton numbers, so here is actually the key, the proton or atomic number is actually at the top. So all the proton numbers actually go in order. So hydrogen has 1 proton, helium has 2 protons, boron, lithium has 3, beryllium has 4, boron has 5, carbon has 6, nitrogen has 7, oxygen has 8, fluorine has 9, neon has 10, sodium has 11, magnesium has 12, and so on and so forth. So as you can see, it's always in order. Okay, and the relative mass number is always at the bottom. So for example, hydrogen has a relative mass of 1, helium 4, lithium 7, beryllium 9, and boron 11, so on and so forth. So this one is not actually in a pattern, but it's more of an increasing trend. So I hope you understood that. So now let's move on. Okay, so next we have the mass number. So let's talk about this. So since the total number of protons and neutrons in an atom is known as the mass number, this means that the mass depends on the number of protons and neutrons as well. So this is also known as the nucleon number. So mass number equals to number of protons plus number of neutrons. So we always know the number of protons, right? Because it is at the top. So for example, carbon atom has 6 protons and a mass of 12. So how do you find the number of neutrons? So in order to find the number of neutrons, you basically take mass number minus protons gives us 12 minus 6, which gives us 6. So there's basically 6 neutrons. Okay, so this is how we actually need to calculate. Okay, and if the question only gives you protons and neutrons, if you want to find the mass number, you need to take protons plus neutrons, or you could just look at the periodic table and find out the mass number for that element. Okay, so I hope you understood what I'm trying to say here. Next up, we have the number of neutrons in an atom, basically the mass number minus the atomic number, like what I was talking about just now. So let's move on. Okay, so next up we actually have the formula, all the formulas that we have went through so far. So first formula, proton, basically the proton number is equal to the number of protons. Okay, the nucleon mass number is equal to the number of protons plus the number of neutrons, and lastly the number of protons is equal to the number of electrons in an atom. Okay, so these are actually all the formulas that we have gone through so far. So now let's move on. Okay, so let's take a look at chemical symbol. So basically this is the chemical symbol for sodium. Okay, so chemical symbol for the element sodium. Okay, And basically when we are writing it, right, so you always thought that the proton number is at the top, right, and the mass number is at the bottom, right, but it's not like that. The mass number is at the top here, so this is actually the mass number, and this is the proton number. Okay, but this is how you always see it in a diagram, normal diagram. So this is the proton number and this is the mass number, but it's not like this in the case. So when you're writing about this, right, so in an exam, so if they give you blanks, okay, you're writing an answer. So basically, so if you write, so 23, 11, and A, so this is how you write stuff. So 23, 11, and A is sodium. So imagine this is the sentence you're writing in an exam, right? You have to represent it this way, such that the mass number is actually on top and that the proton number or the atomic number is below. Okay, if you write it as such, right, if you write it as 11, 23, and A, right, the markers are actually going to penalize you for this. Okay, so you have to represent it as 23, basically the mass number on top, the atomic number below, and then whatever chemical symbol you're going to write. And that's how you represent it when you're writing your answers and when you're writing it in general. Okay, but for the periodic table, it's always mass number below and the atomic number or the proton number on top. So I hope you understood what I'm trying to say here. So please do be careful in this kind of scenarios. Okay, so let's move on. Let's still continue going through this. So the mass number is actually 23 and the atomic number is 11. So there's 11 protons, meaning that there's 11 electrons as well. So there's basically 11 electrons as well. Okay, and so the total number of neutrons is actually mass number minus the proton number, basically 23 minus 11, which is 12. So there are 12 neutrons, 11 protons, and 11 electrons, and the mass number is 23. Okay, so I hope you understood that. Now let's move on. Okay, moving on. So we have to recall. So you see this is actually an atom, and this is an atom as well. So electrons move around the nucleus in regions known as electron shells. So we all know what are electron shells. So you see these things called orbitals or electron shells, right? Right, so these are actually the things that electrons move around in. Okay, okay, next. There is a fixed pattern in how electrons are arranged in an atom. Okay, so these are not great examples of how it should be fixed. So for the two-dimensional figure, right, it will be better if it was perfectly opposite each other. So one atom over here, one over here, and one over here. Okay, so it will be better that way. Okay, but I'm not complaining, this is an image. So let's go on with some examples, I guess. Okay, so arrangement of an electron. So we are going to learn how electrons are actually arranged in the orbitals or electron shells. Okay, so basically the arrangement of electrons. So let's take a look at all the rules you need to obey for the first 20 elements. So the first 20 elements are the elements that most probably are going to be tested. You won't be tested after the first 20 elements. Okay, so always fill up the first shell. Okay, so this is the first shell of electrons. Okay, you are supposed to fill up the first shell, and the first shell can only hold up a maximum of 2 electrons. Okay, so the first shell can only take 2 electrons. The second and third shell can each hold up a maximum of 8. Okay, so this is the arrangement. So basically there's 2 electrons here, and the second and the third shell can hold 8 electrons each. Okay, so if you can see that, right, when I draw this, the arrangement is actually 288 of electrons. Okay, so remember, first shell always maximum of 2 electrons. The second and third shell can hold up to a maximum of 8 electrons. So it doesn't always have to be the case where the second and third shell need to hold 8 electrons. It's always dependent on the element you are drawing this for. Okay, so I hope you understood that. Next. Okay, next we are going to take a look at this. Okay, for an atom that is electrically neutral, the number of protons is equal to number of electrons. So draw the electronic structure of phosphorus. So this is basically the question. So phosphorus actually has 15 protons, that means it has 15 electrons as well, and its nucleon or mass number is actually 31, so meaning that it has 16 neutrons. Okay, because 31 minus 15 is equal to 16 neutrons. Okay, and then the arrangement of the electrons in the atom is represented using the electronic configuration structure, and you can use dots or crosses to represent the electrons. So electronic configuration is 285. Okay, why is this so? Since it has 15 protons, right, it means that it has 15 electrons. So 15 minus 2, because the first shell can only hold up to a maximum of 2. 15 minus 2 is 13, and the second shell is 8, right? So 13 minus 8 is equal to 5. So the last shell holds 5 instead of 8. Okay, so this is basically the configuration that we are drawing it. Okay, so let's draw this. So this is how it should look like. Okay, so basically the first shell, so let's take a look. So this is basically the nucleus, and in the nucleus you're supposed to label the number of protons and neutrons. Okay, let's take a look at the first shell. So in the first shell we actually have two electrons. Okay, so we actually have two electrons over here, 1 and 2. And then in the second shell we have 2, 4, 6, 8 electrons, and in the last shell we are actually having 2, 3, 4, 5 electrons. Okay, so this is how you're supposed to draw your electrons in your number of shells. Okay, and please do remember, when you're drawing your electrons, right, please do try to maintain the same size and always keep it close. So if you're drawing your electron like this, right, is good. So okay, one sec, let me give you a better example. So if you're drawing your electrons like this, right, is a good size and it's also closed. But if you're drawing your electrons like this, right, like this, it's not closed, right? You can see this gap over here, it's not closed, and the markers will actually penalize you for that. And please do remember to close your electrons. And also, when you're drawing your orbitals, if your orbital is like that, right, yeah, and the circle is not closed, right, they will actually minus mark. And please do try to make it remain circular. So try as hard as possible. If you want, you can use a compass for this. Okay, so please do try to like close it. So okay, so you need to close it, and do not leave it like without it closing. Okay, so when you're drawing the circle, right, please do close it. Okay, so just remember, take note of that. Even for the electrons, close it. But the safer way for electrons without this getting the penalized for circle, right, is to just draw a cross instead. Okay, so just draw one cross, two cross. Okay, one cross here and another cross here. So these are two electrons. Okay, so, and always remember one rule. This is very, very important. So when you're having the things, right, when you're having electrons, right, it always needs to be in opposite direction. So there's one electron here and there's another electron here. They are opposite each other. Okay, two here, two here. Okay, there's also two here, opposite each other. Okay, one here opposite each other, one here, two here. Okay, these are also opposite each other because this is an exception, because due to phosphorus having only 15 protons, leading it to having 15 electrons. This means that our only last possibility is to draw it like this. Okay, so please do understand that. Okay, so now that we have gone through that, let's move on. Okay, next, for segment number 4 of this video, I'll be going through the molecule. Okay, so the molecule, this is something we haven't talked about yet. So a molecule is actually made up of 2 or more atoms chemically combined. Okay, so if the atoms are of the same type and if the atoms are of different type. So if the atoms are of the same type, it means that these are molecules of elements. But if the atoms are of different type, this means that these are molecules of compounds. Okay, so the molecule. A molecule of an element consists of a fixed number of one type of atom chemically combined. The hydrogen gas molecule is one such example. So this is basically the hydrogen gas molecule, and this is represented using ball stick models. So the balls are actually atoms of hydrogen. Okay, hydrogen atoms basically. And each molecule of hydrogen gas consists of 2 hydrogen atoms, and this stick over here is actually the force that holds these 2 atoms. Okay, so this is important. Okay, so this is the molecule of an element. Okay, molecule of an element. Okay, so I hope you understood that. Now moving on. Okay, the molecule. So many other non-metal elements also exist as molecules. For example, chlorine and nitrogen. So these are actually non-metal elements. They also exist in molecules. So basically, chlorine gas actually is a molecule as well. So each chlorine molecule consists of 2 chlorine atoms. Each nitrogen gas molecule consists of 2 nitrogen atoms. And you know oxygen gas, you know how we always write it as O2? You know oxygen gas. You know whenever we write oxygen, right, we always write O2, right? This is because it actually has 2 oxygen atoms. Okay, so when we are writing nitrogen gas, right, it's actually N2. Writing chlorine gas is actually Cl2. Okay, so I hope you understood what I'm trying to say. Okay, okay, now let's move on. Okay, next off we have the molecule as well. So a molecule of a compound, so now we are going on to a different part. We are talking about the molecule of a compound consists of a fixed number of different types of atoms chemically combined. Okay, so the water molecule is one such example. So the water molecule is actually made up of hydrogen and oxygen. Okay, it's a ratio of oxygen and hydrogen atoms is fixed regardless of the state of water. So basically it is 1:2. Okay, sorry, this applies to molecules of all compounds. So basically hydrogen the water molecule is represented as such. So you can see the ratio, right, is that it is 2:1, hydrogen is to oxygen. Okay, so hydrogen gas, that's basically 2 atoms both connected with a stick and 1 oxygen atom. Okay, and this is actually the molecule that gives us molecule of a compound. Okay, and this is actually water. Okay, and each water molecule consists of 1 oxygen and 2 hydrogen atoms. Okay, so this is something that we need to know. Okay, and this is regardless of any state of matter. Okay, so if water was ice or gas, right, there will always be a hydrogen, 2 hydrogen atoms and 1 oxygen atom. Okay, so I hope you understood that. So now let's move on. Okay, next off we have the chemical formula. So we use chemical symbols to represent atoms. On the other hand, we use chemical formula to represent molecules. So the chemical formula tells us the types of atoms and the number of each type of atom in one molecule of a substance. Okay, so I hope you understood that. Now let's move on. So the chemical formula is basically like, for example, ammonia is NH3. Okay, meaning that it has 1 nitrogen and 3 hydrogen. Okay, so this is how we represent it. So you can see that there's 1 nitrogen atom and there is 3 hydrogen atoms. So this is the chemical formula that represents. And imagine like water. Okay, water is H2O. Okay, this is a chemical symbol. Okay, carbon dioxide. Carbon dioxide. Okay, what is carbon dioxide? Carbon dioxide is CO2. This is one carbon atom and 2 oxygen atoms. So all of these are actually chemical formulas. Okay, so when there is no number beside the symbol, it means that there is only 1 atom of the element present in the molecule. Okay, and hence there is 1 nitrogen atom in an ammonia molecule. The small number beside each symbol is called a subscript. So you see this number over here, see this number over here, you see this number over here is called subscript. Okay, so this is basically tells us the number of atoms of the element present in a molecule. Okay, hence there are 3 hydrogen atoms and in an ammonia molecule. Okay, so with that I have come to the end of this video and I hope you have understood whatever I have taught you today. Okay, so please do remember this chapter, it is actually really important, atoms and molecules. Okay, thanks for watching everyone. I hope you have enjoyed this video and understood more about secondary 1 science, the 8th topic of atoms and molecules. And I hope this video really helps you, and if you are not subscribed to Nithin Academy, please do subscribe, a part of our family. Thank you and bye bye. I'll see you again in our next video. Bye.